Hey Titans, this is Mr. Spilker here, and I am going to go ahead and cover Chapter 6, Section 1. Chapter 6, Section 1, and that is solving one-step inequalities. So go ahead and get that heading on your notes. 6.1, solving one-step inequalities. We really just have one glossary term that we're going to go ahead and focus on, and that is an inequality. An inequality is a statement that two expressions are not equal. So when we talk about solving inequalities, what you're going to notice here is we're going to swap out that equal sign for one of the four inequality symbols. All right, so an inequality is a statement that two expressions are not equal. The addition property of an inequality and the subtraction property of an inequality, at this time I don't believe that's important for you to put down into your notes. All right, let's go ahead and cover the rules and properties here. And basically what we're trying to do is just fill you in on the translation of the different inequality symbols. So first of all, we have A is less than B. Obviously the less than symbol is an L that's been pushed over. All right, it points left. Less than points left. Greater than, the greater than symbol, greater than points right. Less than or equal to, we put the line underneath the inequality symbol for or equal to. And a lot of times if you translate that in terms of an application problem, you may see the phrase at most. At most means greater than, or excuse me, means less than or equal to. You'll see the phrase at least. At least means greater than or equal to. Greater than or equal to. So anytime you're doing an application problem and you see the phrase at least, we think, well, least sounds like less than, but that's kind of a tricky one. At least means greater than or equal to. Then we have some of our combination statements here, where we have A is greater than B and less than C. So that means that A would be between those two. So that's how we write that something is between those two values. A is greater than or equal to B and less than or equal to C inclusive. Inclusive means we're going to have the or equal to. That means we're going to include the values that it is between. And then A is not equal to B, the not equal symbol, there is the equal sign with the slash through it. So those are the different inequality symbols that you need to be aware of. All right, let's go ahead and jump into some real life examples of inequalities. Here we have the Bulls are greater than the Heat. Okay, obviously the Bulls are much better than the Heat this year. They got Doug McDermott. LeBron's gone. So the Bulls are greater than the Heat. Another real life inequality symbol we have here is baseball. We have the Yankees are less than the Red Sox, who are less than, obviously, the king of baseball, the Royals. And as I'm saying that, I am jinxing them. They're probably going to lose the rest of their games this season, but oh well. So those are real life examples of inequalities. All right, let's go ahead and jump into some examples of translating some different phrases into inequalities. Right here, the directions are to take these examples and write an inequality for each. So the interest rate is less than 1%. Well, we don't know what the interest rate is, so we'll use R. It's less than 1%. R is less than 1. The temperature was more than 52 degrees. That means the temperature was greater than 52. A is at most 10. So if A is at most 10, that means A has to be less than or equal to 10. Once again, at most is one of those kind of tricky phrases. It's less than or equal to. X is at least 100. That means X is greater than or equal to 100. At least is greater than or equal to. R is positive. If R is positive, that means R is greater than 0. Q is non-negative. If Q is non-negative, that means it has to be greater than or equal to 0. We want to include 0 because 0 is a non-negative number also. M cannot equal 0. M cannot equal, so an equal sign with a slash through it, 0. V is between 4.5 and 4.6 inclusive. So 4.5, 4.6, and since it's inclusive, we say or equal to. So there are some quick translations with the different inequality symbols. All right, now the great thing about solving inequalities is you solve them just like you solve an equation. So we don't need to go through a bunch of, okay, folks, here's how to solve inequalities, because we have spent quite a bit of time this school year solving equations. So we can jump right into solving inequalities. You solve an inequality just like you solve an equation. So you would solve x plus 7 equals negative 11 the same way you'd solve x plus 7 is less than negative 11. The goal is to isolate the variable, so we would subtract 7 from each side. So our answer is x is less than negative 18. That's simple. You solve inequalities just like you solve equations. You may want to put that into your notes there. That's very important. You solve an inequality just like you solve an equation. All right, Titans. Now, when we solve these inequalities, there's not just one answer. There's an infinite number of solutions. So not only are we going to solve these, but we're going to also graph them. So when graphing, make sure the variable is always written on the left side of the inequality symbol. When the variable is on the left side of the inequality symbol, here are your directions for graphing. These are very important. I would add them into your notes right now. When x is less than your solution, there's an open circle and you shade left. When x is less than or equal to, closed circle, shade left. When x is greater than, there's an open circle, shade to the right. When x is greater than or equal to, closed circle, shade to the right. Now, the pattern you should be noticing here is that whenever you have the or equal to symbol, you're going to have a closed circle. And you should also notice whatever direction the arrow points, you shade that way. Arrow points left, shade left. Arrow points left, shade left. Arrow points right, shade right. Arrow points right, shade right. Now that rule works only when the variable's on the left side. So make sure when you get done solving your inequality that you have it written so that the variable is on the left side. Then you can follow that simple, easy rule for shading. All right, let's go ahead and add this example into your notes. This is an example of solving an inequality. So we have the inequality x plus 12 is greater than or equal to 16. So to solve this inequality, I'm going to go ahead and subtract 12 from each side. When I subtract 12 from each side, that leaves me with x is greater than or equal to 4. So on my number line, since it's or equal to, I put a closed circle on 4. And then since my variable is on the left side, I can follow our rule for shading, which is shade the direction the arrow points. So I can shade to the right. Points right, shade right, as long as the variable is on the left side. There is an example of solving an inequality. All right, two more examples of solving inequalities. We have m minus 8 is greater than or equal to 2. So to solve this inequality, I need to isolate the variable m. So I'm going to go ahead and add 8 to both sides. When I add 8 to both sides, that leaves me with m is greater than or equal to 10. And then obviously we're going to graph that. Now when we graph these on our own, myself, Mr. Simpson, and the one and only teacher of the week, Mr. Wills, ask you to go ahead and put in 3 numbers. That's all we ask for on the number line. Just give us a quick, simple 3-number number line. So I give you 9, 10, and 11 with my answer in the middle. I'm going to use a closed circle on 10 since it has the or equal to, and then it's going to shade to the right, the numbers that are greater than or equal to 10. That simple. Let's try another one here. Let me clear my slate. So I'm going to go ahead and grab the eraser here and clear things off. Let's try the second example, and this is our last example of the evening. So our last example of the evening here is going to be 5. Oop. I'm using this for the first time here. They updated the software, so let's go back to that. 5 is greater than x minus 3. So to solve this one, we want to get x by itself. So we go ahead and get rid of the minus 3 by adding 3 to both sides. So 5 plus 3 is 8. 8 is greater than x. That's my solution. Now, we always recommend to students that they rewrite it so that the variable is on the left side. As you can see, when I got done solving, the variable is on the right. So I'm going to go ahead and rewrite this. Now, the arrow is pointing at x, so when I rewrite it, I always want to make sure the arrow is pointing at x, just as it was before. In other words, when myself and Mr. Simpson and Mr. Wills talk about this, we always say when you rewrite it, don't change the alligator's diet. The alligator was eating, you can see him, he's chomping on x. So when I rewrite this, he better still be eating x. Don't change his diet, all right? You don't want to make an alligator angry. You could possibly lose a limb. So there is another example. Now we're going to graph that. So 3-number line. So I'm going to go 7, 8, and 9. It's an open circle this time, no or equal to. And since the arrow points, and remember I got to go off of this one right here. Since the arrow points left, I shade left. All right, Titans, that's our lesson. Hopefully you enjoyed it. Please fill out the Google form below and come ready to practice this in class. Thanks for listening, Titans. Stay classy.